morning, everybody. Good afternoon or good evening, depending on where you are. It is an early morning here in Vancouver, and I'm glad to be here with everyone for the BPI's. Guess we're on number 5 today. This is pretty exciting.
Hi, and welcome everyone. My name is Julia Potter of Martel, and today I'm keen to hear and learn more about PHribbon from our panel of green building experts. Thank you.
Really looking forward to this one, or kind of have been looking forward to this one. For me, kind of embodied carbon and operational carbon, it's pretty much the most important area in construction right now, and we really need the knowledge, understanding, and the uptake to really influence industry as much as possible. So really grateful for Tim and Ben for today to help illustrate and maybe show how this can all work and what it means.
Yeah, Mike Jacob, co-founder of Kiss House. As ever, it's a great pleasure to be here. Really looking forward to Tim's presentation and film. Hello, everyone.
Yeah, and I am Ben Adam Smith from the website houseplanninghelp.com. And embodied carbon is something that I think is particularly important. And I'm sure we've all known about it, but the importance of embodied carbon has grown. You know, perhaps we're very much in the passive house circle here, but I think that is the flip side, upfront emissions. We've just got to think about so many different aspects. So I'm going to give you a bit more background on our guest today. It's Tim Martel. He's a chartered architectural technologist and passive house designer with 2 decades of experience. He's done energy modeling for new build and retrofit projects. He's worked with Simmons Mills Architects, also Warm, which is a leading UK passive house certifier. But these days, well, what's taking up a lot of his time is he's the developer behind the AECB's PHribbon. So that's the Association for Environmentally Conscious Builders. And it's quite interesting where this came from. It was a retrofit costings spreadsheet that they put together that they just built in more and more functionality. So it's taken on a life of its own. It's a tool that's really useful to help you model whole life carbon, and that's why we're going to explore it some more. Now, I thought it would be interesting because I've built my own house and I had to make all these decisions as we went along to reflect on that a bit. So it's a masonry house that I built. I've lived in since we completed in 2018. What was my thought process at the time, and would I do anything differently? So we put together a quick video on this.
Hello, I'm Ben Adam Smith from House Planning Help website, and this is the house that I've lived in for over 3 years now with my wife and 2 kids.
As you might expect, it's been comfortable all year round. The air is fresh, it's an even temperature across the house, and it's lovely and quiet. Just a great place to live. But I wanted to share a bit more about the journey. I started dreaming of building a new house in 2012. Our first home was fantastic, but it was the usual story.
We just need more space, really. It was fine for a couple, but now we've got little James. We need a bit more room, particularly with us both working from home. Yeah, okay, Munchkin.
It wasn't until late 2016 that it became a reality when we finally bought a piece of land. One big plus of spending many years trying to make it happen was that I had a fairly strong idea of who could help us. I'd visited a number of Parsons and Whitley schemes. They were passive house specialists, which I liked, and I also felt that they could help us bridge quite an interesting gap.
My wife Kay has always liked a traditional aesthetic, whereas my tastes have changed over time, and I'd certainly be open to something more modern. I felt that Parsons and Whitley were perfectly placed to help us. So first, we briefed them about how we'd like to live in the house.
What we were really looking for was to try to understand what your priorities were. Obviously, what accommodation you wanted, you know, how many bedrooms, all that sort of stuff. What were your priorities in terms of materials, in terms of the sustainability aspects? You know, what actually did you want? That's what a brief taking is about, really, to find out exactly what it is that you're looking to achieve and make sure that we can deliver that. And then, of course, obviously, We looked at the site so that we could get a bit of an understanding of what the constraints, opportunities were with the site. So we come away from a brief really with a good, clear understanding of what you as a client are trying to achieve, and a beginning to get to grips with the problems that might present themselves en route to getting to where you want to be. Just, we talk about constraints and opportunities all the time. What are the constraints that the site presents? What opportunities are there?
The plot has a couple of constraints which limit what we can build. Firstly, there is the proximity of the neighbours. And secondly, the greenbelt runs through the middle of the plot, and we can only build on the side next to the neighbours. With this in mind, the architects produced plans for a house which would fit on the site and be a passive house.
It's kind of deliberately vague in terms of materials. We want to come to materials a little bit slowly because we can paint this building with a number of different materials. This is about finding a form and really making sure we can get all of the accommodation in, etc., etc. We'd already spoken to the planners, so we had a bit of an idea as to what sort of thing they were looking for. The site already had an extant consent as well, so we're trying to operate within the constraints that illustrated to us. Obviously, in a passive house, we want to try and keep a simple form. I think we've spoken about quite liking the sort of agricultural barn type aesthetic. So again, that was sort of introduced here. But nonetheless, it's got to be domestic, obviously. So we've got garages, we've got a little porch.
We were also sent a floor plan, and we gave feedback on the internal accommodation, which just needed a few tweaks.
It didn't take long to sort out the floor plan. As you say, this first one we sent you, I think we'd put the kitchen in the middle and you're sitting in the snug, etc. And that was one of the comments that came back. So, I mean, they're quite easy really for us to change the floor plan around.
The floor plan drawings also gave us a site plan and showed us exactly where our house would be situated.
This illustrates one of the constraints with your site really, because this is the whole site. But we're stuck with putting the house where we need to put the house because of the greenbelt. When we spoke to the planners, they were pretty adamant about keeping the siting in line with the earlier consent, so we decided not to challenge that.
And that wasn't the only comment the planners made about the SketchUp plans.
They pointed out then that we'd need to be careful with height because that's quite a steep pitch, which is something we wanted. But there was the potential for that to overshadow the neighbour, and they said it's something we need to be careful of. Following that meeting, we've reduced the pitch on the roof and we've introduced a cat slide at the back. So now we've lost the height issues. We've reached agreement on materials in terms of the lime render and the brick plinth, all of which were what you were looking for. So this was like a eureka moment, I think, once we'd had that meeting.
So how were we going to build it? I'd always liked the idea of using straw, but when it came to making the decision, I must admit I got cold feet. Perhaps it was the thought of having so much money invested in the house and maybe then putting myself at the point of selling the house and worrying that it might be hard to do. Parsons and Whitley had built with straw as well, but they'd also completed a number of masonry passive houses. And if I'm honest, I was interested to learn about this approach because it's still very common in England.
The skills, the materials are all available for everybody. We all know how to do it, there's just more of it. In terms of airtightness, again we're using a wet plaster system, so very traditional method of construction, and plaster is airtight. But of course it means attention to the junctions, so particularly across the floor joists at the roof level. We'll be using membranes and tapes around windows and the like, just to make sure that we get the airtightness right.
Although I was aware of embodied carbon when we built, there's no doubt that it's become more and more important. Certified passive house designer Tim Martel is an expert in this area. He's the developer behind PHribbon, a very useful tool that we're going to explore. He's going to give me a demo of how I could go about calculating the embodied carbon of my home. First though, what is embodied carbon?
Well, it might make more sense for me to just show you a little bit of a presentation on that, because there are a few terms which are a little bit confusing on this. So if you were to just look at the embodied CO2 of the construction of the building, what you'd end up with is something that looks a bit like this. We've got three different passive house buildings of different constructions, you get quite a different result from each one of them. There's some timber storage in them, and they are all to do with this manufacture process, what we call stages A1 to A3. Now, that's not embodied carbon as such, that's a component of it. But if we were to add the transport to site and the construction, we call that upfront carbon. You can define that as embodied carbon. Some people do, because the term isn't exclusive to being whole life, but the better way of looking at embodied carbon would be to look at the whole life of the building. So to do that, we would include the use of the building there, and also the end of life, which includes disposal. And that's a much more of a robust method of looking at the carbon, because it includes all the irregularities that are created from the replacement of materials which have a short life, and the end of life. Some materials have a bigger influence than others. And that's why it's much more useful to do it whole life carbon. And the only thing that whole life carbon adds, which embodied carbon doesn't have, is it has this beyond life stage D and the operational carbon. But essentially the embodied carbon is the CO2 from the materials of the construction of the building throughout the life of the building. At least that's the most useful definition of it.
Tim, you're going to have a look at the PHPP model of the house that we built. So I've lived in it for 3 years. Can you take us through calculating at least some of the basic elements of embodied carbon?
Yeah, it's quite easy, yeah. What PHribbon does is it takes a lot of the information from your PHPP. And that's really handy. That means all the areas are, well, they're already in. You've spent a lot of time putting together your PHPP, so might as well use that information. Or the list of materials. You might have gone into a lot of detail about the materials. Even if you haven't gone into detail, we can match a few things up. This is PHribbon at the top here, and it's a menu in Excel which is added to the top. This whole area at the top is called the ribbon, in fact, so that's how it got its name. The process is quite straightforward, really. Here we've got a description of the materials in the PHP. This is the U value tab, and if we start the embodied CO2 here, then it asks us if we want to start a new calculation, and yes, we do. So it will then create a new sheet, add that to your PHP. There it is, new sheet in your PHP. And then we start adding materials from that same section. Just the section that we were just looking at there in the U values, it's going to go through that, and we've clicked on plaster, so we can choose from a range of plasters. This is a context sensitive list, and we write that, and then we can go on to block work. There's no materials called block work. There are materials called blocks in the library.
When you say the library, what exactly do you mean? Where is it getting the information from?
Well, PHribbon, part of what PHribbon is a big library of materials. There's about 400 materials in there from EPDs. I think it's another 100 and something from the ICE database. And those do get updated over time. I'm continually updating those. So we just go to a suitable type of block. Here's a concrete typical medium dense block, although it looks like, we'd have to confirm, but it looks like a lot of the blocks you're using there were AAC blocks, so we'd have to find out exactly what type. Anyway, we would choose one of those, and then we can even add, to save you entering things, we can even add a few entries together. So add that 100 to that 100 and write that. And then if it's a bit vague, like insulation, then we can you could use the search box here to specify exactly what type of insulation, then select it there. And when you come to add the other things, you've got windows you can add. There's a dialog for windows. There's also finishes, because not everything that you need in the embodied part is actually in the PHP. There's a lot of the structure which isn't thermal. So the internal walls, for example, no need to model those in PHP. It's not really relevant. And the intermediate floor, that's the floor, the construction of the first floor itself. No need in PHP, it's not even relevant. Or the roof tiles in your case, then you wouldn't model the roof tiles as such. So roof tiles aren't in the PHP as well, but you can add them with this other button, and you can also add all the services that they get added in these other ones as well. So that's how it works roughly.
Tim, just to finish off, I thought I would take you through a few of the key stages of the build. I imagine with your head down in PHribbon, you don't always get to see the builds.
Yes, that's right, yeah.
So this is probably where most of the embodied carbon goes, into the concrete foundations and the beam and block floor. It's a cavity wall construction with 150mm of earth wall insulation nicely packed into the cavity. There's the one steel that we have in the building, driven by the client. I think Parsons and Whitley had tried to iron that one out, but we wanted an open plan kitchen area, kitchen diner. And then we're up to the first floor, seeing the roof go on, the trusses, and clay tiles, again, something that would have been fired. This is the air tightness layer on the first floor, and then there's a false ceiling below that. Here's all the stud work, windows going in as well. And below us, we've got more insulation, which is then covered by a screed. I think there's also an air tightness membrane down there. Gypsum plaster providing the air tightness layer on a lot of the building. And outside, we've got that lovely lime render.
Initially, I had looked at the house as a straw bale house. That was definitely a consideration. What impact do you think that would have had compared to the masonry house that we have built?
Straw bale is very low carbon. It's not only the straw, but if you have it in a modular system like EcoCocon, well, they extract carbon from the atmosphere. Really, it's a negative carbon thing from the very start. And even though it is released at the end of life under some circumstances, it still ends up being lower than concrete or brick, or having timber or some form of timber. It still ends up lower. And I think in reality what's going to happen, of course, though, is within 30 years time, 50 years time, we're not going to be burning straw and wood, and if we've got any sense, we'll be having taken all this carbon out of the atmosphere. We will have developed a way of keeping it out of the atmosphere and storing it somewhere permanently. What we've done by having a straw bale house or a timber house is temporarily stored that carbon in the house. And if we can recycle that house into other houses for the time being, or even at the end of the life of all the various different houses, if we can deal with it in a way that doesn't go back into the environment again, then that would be the very best way. Well, I thought it might be interesting to actually carry some of those thoughts on and look at those options. We talked about what it would be like if it was made out of straw. Well, I've actually modeled that to some extent. Normally what you'd do is you would refer some of the queries to the architect, and there would be a bit of toing and froing just to make sure all the materials are right. To save time in this case, I have made some assumptions, but you'll get the general idea of what we have. And it also, I don't model the whole thing. I'm just looking at some of the basic structure. But what we're going to look at is three options. The first option is going to be the building as built. The next option is going to be using the structural straw in the walls instead of the walls that were used. And then the third option will be to have those straw walls and replace the floor with, instead of the the floor that we had there, a solid floor with 70% GGBS. That would be a Raft Foundation. Now, I'm not suggesting that this is necessarily possible in this situation, because I haven't discussed it, and I'm sure there are very good reasons for doing it the way it was done. But this is just an illustration of what you could do and the way you would consider another option, and how you'd go about it in PHribbon. You could compare the other thing and see what it came out as. So firstly, then, this is what the general result looks like. In PHribbon, this is a collapsed view. In other words, a simplified view, and it's a list of materials. You can see a list of materials in yellow here. This is a shorter list of materials. I'll show you a full calculation later, but then it's a heat map. So on the right, we have, against all those materials, we have different colored cells, and the ones that are most red are the ones that are emitting the most CO2, and there are some which are green as well that absorbs. That's showing absorption of CO2, so sequestration from the atmosphere. So actually, funnily enough, this eco-cocon down here absorbs a lot at the beginning of its life when the straw is being grown, and there is a potential for that, if it's incinerated, to be released. If it goes to landfill, it may be that there would be less, perhaps. So, well, that's at least what the calculation says. And one of the largest ones here is the AAC block work. I did assume in there in the introduction, the previous video, I was looking at using other blocks, but I did go back and use AAC, and we've got the lime render there as well. So this is this column here, option 1. These ticks indicate that this is the option as these materials, sorry, are going to be included in option 1, and you can just tick whatever is appropriate for the other options too. So when we go to the second option, we untick those and we use other options down here instead. So we add new materials and then we tick those instead and take the ticks out of the top. And with option 3, a similar kind of thing, where instead the thing that's being replaced here, we've got none of the original walls. We've also taken out the original, the beam and block materials there. So that's unticked there. And then we've got replacement materials down here. So it's relatively easy to use. There is a bit more behind it. You can unhide all the figures in the middle, and then that will show you all the detail, but it's quite nice to see this collapsed view. And if we look at the results of that, well, firstly on the left, we've got the embodied side of it, and that produces these graphs of the embodied CO2. The orange part is the materials that are the manufacture of the materials. The various different oranges are the different types of construction materials subdivided. And then, just as before, when we were looking at the colors before, we have A4 and use, and then the end of life. So this option 2, where we've got straw in the walls, that's got a lot of, well, I'm still calling it timber storage, it's really straw, but that's got a lot of storage there, and a possible corresponding emission at the end of life. And the same for option 3. Again, same straw, same emissions, but you've got also some GGBS as well. And on the right here, the original as built would be reduced a fair bit, at least initially, by changing to straw. The only thing is that if we were looking at what happened at the end of life, then it could end up in around about the same place if we didn't deal with the straw very well. If we actually incinerated it, then it could end up more or less the same as the other one. But if we were sensible, which I hope we will be in 30 years' time, it would be better. And there is a benefit of actually dealing with the CO2 now. As far as the IPCC are concerned, they actually give a credit for dealing with the carbon now, because now is the time where we've got the problem, and in 30 years time the carbon emissions will be much lower, and the damage that we're doing will be less. Anyway, I thought it might also be interesting to look at a fourth option. So what I did was I took the same option 3 and I extended it a little bit in order to consider what would happen if we'd put a heat pump in instead. All the previous options, all the first 3, use a gas boiler as the heating method for the heating and hot water. The heat pump, well, it uses a rather conservative idea of the emissions from the electricity. It assumes that the emissions would be what's known as a steady progression, which is rather unambitious, really, and it assumes that we'd just get to net zero in about 50 years rather than actually when we're supposed to be getting to zero in 30 years. But you can see it kind of levels off, and you still have the replacements of various things, and yeah, it's clearly lower, even though you've got this little jump at the end. And if we'd done a full calculation, well, this is an example that I did for the Passive House Plus magazine, and if you were to do it in full, then it's the same kind of process. I just thought I'd show you, though, some houses are a little bit more complicated, and you'd have 2 pages of items. They're still not that bad to put in. On this second page, we've got the intermediate floors, the internal walls, all that detail, which we haven't actually got in this example because I've kind of shortcut that process slightly, just to produce something for the presentation. And we've also got information about heat pumps and services and all that down there. I should also mention, because I know we have some people watching from Vancouver, that this isn't just something that's available for UK using UK data. It's also available using US and Canadian. There are US and Canadian versions of PHribbon, which both use the EC3 database, both use these 44,000 records that we've got there at the moment, soon to increase to about 80,000. And they use the EPA CO2 factors and end-of-life emissions data from the US and Canada, and end-of-life pathways. So that's probably worth mentioning, and therefore there are corresponding different places to get more information on that. And I thought I'd leave you with a final slide which actually mentions some of those other organizations. It's Passive House Canada. There's a link there for if you get to the Passive House Canada website, it will be fairly obvious when you go to the software part of it where that PHribbon stuff is. And again, with the Passive House network in the US, you've got the Imperial version there if you want to work in Imperial, and they have a link to their own version of PHribbon, which I wrote for them as well. Thank you very much.
So I think, Tim, thanks for that. That's amazing. And there's been, I guess, so much talk about PHribbon. You see it kind of in the community, and I think it's really cool and important for people to see that it's that easy to use. It's not really an obstacle. If it's in a certified passive house, it's extremely easy, but really it's an accessible tool kind of for everyone. So yeah, it's really important for us all. I had a few kind of takeaways, I guess, as I was looking into this maybe before I came in, and the slide on operational carbon is kind of enlightening, I guess. And it's probably an easier one for people to manage and deal with, and that maybe the path or the decisions are kind of already there as to how we might manage that. But embodied carbon, I guess it seems like we need to be very careful about the materials that we choose, kind of. So I think in a lot of the choices we take, we're using maybe materials that aren't locally produced, and there's often a pretty good alternative, or maybe there's a less dense alternative. So, is the structure, which I guess is kind of 3/4 of the embodied carbon, Tim, would that be about right?
The structure, yeah, I think it probably would be in many cases, yeah.
So that kind of potential for moving to more lightweight structure should be a really big kind of percentage change in the embodied carbon. And I suppose outside of that, the one that really kind of hits home is building longevity. That could be our heat pump, the wall fabric, whatever we choose. The decisions we make about what materials are chosen. It's a single cost, and the real cost is the initial construction. So maybe the less remedial works, or how busy it is, maybe even the house design, is it efficient? Those kind of things have just a huge impact on the overall carbon spend. So I don't know what you think, Mike or Ben.
Yeah, well, I'll go next. Lots of interesting points there. Also, spreadsheets. I never know where to look. So I'm very pleased that you had your cursor going around the screen so we could check it all out. Well, I think one of the most important things for me, I like the idea of being intentional. So when you go into a project, okay, admittedly, self-builder, doing it first time, it's going to be an experience where you get information overload. But if you're more intentional and you've got the answers in front of you going in, I'm quite looking forward to. I've seen that Chris Parsons, who you saw in the video, he's on the call as well, but he's had a career running an architecture firm with all these things to balance out. And even since he retired, I'm wondering whether things have changed. So Jay, if you can bring him in at all at any point, that would be good. But the other thing I'll say is that when we targeted Passive House, for example, it comes with a lot of benefits that I believe give you a better living experience. And possibly some of the materials with the lower embodied carbon, maybe they also contribute as well. Certainly a lot of the straw panel buildings that I've been to and the timber frame building, just those plant-based materials, I think has a different impact. But those are my main takeaways. And yeah, I don't know whether Chris is there. Are you there yet? Or shall I throw to Mike?
Yeah, I'm here, Ben, and hello, everybody. I haven't got a lot to say, really. All very, very interesting. And Tim, that's fantastic, the work you've been doing on that spreadsheet. Just in terms of the embodied carbon aspect, I think it's really grateful to you for showing that little bit which we did when I was taking your brief, because you'll notice that I specifically asked you a question there about what was your priority in terms of sustainability and such issues, because as an architect in general practice, it's always a balancing act. And all those other architects who are watching today will know exactly what I mean. Between all of the other constraints that we've got to deal with, what's the construction industry capable of at the time we're going into it? What's the skill level? What's the budget? What's the cost? There's all of those things that have to be balanced. So the intentional aspect of it, I think, which you just mentioned, is really important. If you've got a client who wants to do it, then we can do it. And it's just, trying to gauge whereabouts that is in the sort of scale of things we're trying to produce.
Right, handing over to you now, Mike.
Yeah, thank you very much. And it's really great that Chris is here as well as you, Ben. I thought it was very interesting and very open of you to showcase your own self-build project and to talk about that so honestly. I just took a few notes. One thing that stood out to me, and maybe this is for Chris, was the use of the kind of the language. We can paint it with any materials you like when talking about the planning stage drawings and looking at this white box model. I wonder if the language would be different nowadays, but things have moved on a lot in a short space of time. So it's just a question there, maybe for the architect, but a question for you, the client, Ben, is the obvious question is, would you build a straw bale house today? And are you going to?
Yeah, very good question. And I would love to, but I still think there is, maybe it's a social economic thing that I need to get over. You know, a lot of my money is tied up in this house, and being straw, it might be just absolutely nothing. Maybe I'm just making it all up, but it's still something to get over. And yeah, throwing back to you, Chris, as well, you know, something you had built straw bale social housing. Why, what were your takeaways from that? And, or is it just every project as it comes and the priorities?
Well, I think for us, it was always driven by the client. So that the straw bales that we did for House Housing Association came from a request from that client to explore the possibilities. It was very interesting for us. It's the first thing, you know, we hadn't done one before. We wanted to find out what the issues were. There were quite a few. I won't go into them all now, but you know, we overcame them and we developed and delivered. I think it was four houses in straw bale, and they're still going very well. So always for us, driven by the client. You know, what's the incentive for the client, and we can do it. As to whether we would do something different now, Mike, you asked that question. I've been retired 3 years, so I'm not going to be able to answer too much. But I've stayed well in touch with what's going on, and it would be probably elevated up our list of questions. I would say is probably where we would be. I think we've begun to understand since we started that project how important embodied carbon is, and certainly it would be given a greater priority in that brief taking.
Thanks, Chris.
I'll just add something else, Mike, just before you kick off again, that you know, there are other factors as well. For example, scale. If I'd really wanted to make that much of an impact, and this comes back to your initial brief taking again, you know, there are so many different factors that really make a difference. Sorry, I interrupted you. You go.
It was a question for Tim, actually, and thank you, Tim, for presenting PHribbon. It was really insightful. That's a really good work there. I just wondered if you could comment on the big difference in the demolition and disposal emissions in options 2 and 3 versus option 1.
Oh yeah, okay. Shall we have a look at it again? Shall I share it again? Well, the demolition and disposal, the reason that options 2 and 3 are larger is because that is the disposal of the straw, and the straw is being, the assumption here is that it's being incinerated, and that is a typical assumption of RICS, which is the Royal Institute of Chartered Surveyors, who formed the rules that we use, or that they provided a professional standard that we go by in this country. And they say in the absence of information, you try and align with these parameters, and so that's what we've been doing. So the demolition disposal, it's saying that at the end of life, the carbon emissions from the straw would be, there won't be nothing. There will be some quite large emissions, possibly. But as I also mentioned, whether that actually materializes in reality, I hope it doesn't.
Are you able to enter non-standard inputs if you knew and were able to prove that you were not going to burn it?
Well, you can do a few things. You can recycle the building. You can, if you design the building to be deconstructed, you can reuse parts of it. You can reuse quite a lot of materials. That gives you some quite large credits. You can add your own materials. If you've got some novel new materials, then you can add those to the database. You don't need me for that. You could add them yourself. And so I think from the point of view of saying, well, this wouldn't be burnt and therefore we can just get rid of it, you can't quite do that, because that wouldn't be fair on everyone else. We're trying to standardize the whole calculational approach according to RICS. And then if everyone could decide what happened at the end of life, well, then we wouldn't be able to compare buildings. So there is a certain amount that has to be kept standard, but we can still work around that. And then different materials have different effects, really.
Tim, if you were building now this type of project yourself, as somebody who's kind of looked more closely at this than anyone else, how would you approach it?
Ah, well, okay. That's an interesting question. I think let's look at the number down here, because, you know, I was saying that it's not the height of the bar that's important here. You've got a positive part and you've got a negative part, and they get added together. So, or subtracted, if you look at it that way. So this positive part of 300 and what, that's 350, something like that. You subtract 180, something like that. And then you get this RIBA output figure. So the option 1 is 199, let's call it 200. Option 2, the overall net, can you see where my cursor is?
Yep.
I'm right down the bottom right. 170, which is a fraction lower, not massive amount lower. And then the other option 3 is 180. I think the reason why that's higher instead of lower, because obviously we're using GGBS to try and reduce carbon, and we've ended up with slightly more. So I think the reason that's ended up slightly higher is because I've assumed you'd have a solid slab of 200 millimeters of concrete, reinforced concrete, whereas the original one was actually really quite thin. The beam and block floor is very thin, and perhaps that's why they have inadvertently increased the amount of emissions by putting in even a low carbon form of concrete there. So what I'm saying here is the overall result, if we take this emissions at the end of life to be included as it stands, the overall result isn't that much different from all of them at the moment. So I would say it's up to the client which they want to go with. I wouldn't be pushing in a particular, the figures don't suggest a radically different result from all of these. Yeah. But I think going into the detail, you could refine these and get a more nuanced result if you wanted to go that far.
Yeah, cheers. No, that's interesting. I guess it brings it back to the form and you know, maybe the operational and I guess what the building consumes overall. But it's not one easy part, is it? It's everything together to you know, make an informed decision, and that's really what the tool facilitates.
I think we should throw over to Sean and get some questions, because I've been seeing them fly by. So if we can answer any of the questions now, and that can be for anyone, by the way.
Yeah, there's a lengthy discussion. It's going to be great. There are a few people that have got a few, so I've kind of put them in the queue again. I'm just going to dump that into the chat. Bear with me. We'll get okay, so there's the queue. Let's hit that magic button. So we'll get Irene to kick things off. Irene, come on and ask the question. And just before you do, great discussion by all. I know there might be some overlap, and if we have to rediscuss some of the questions that were posed, we will definitely do that. Again, this is just fascinating. I can't wait to start using it. So again, Tim and Ben, it's great that we're starting to see this. Love the history of how this was developed. And I always think of, again, this might be a little bit odd, but again, it's still early in the morning here in Vancouver, so my mind's not working fully, but I always think of the 3 pigs and wolf story when we get into the ribbon about we can build a high performance house. We now have 3 material choices to do it. Now, depending on what your PHribbon decides is maybe the best approach, you can go ahead. But no matter what, the wolf won't be blowing down the passive house, which is fantastic. We just have 3 different views of how we're going to look at it. So, Irene, if you're with us, if you want to ask your question, I know you're in the queue a couple of times, but go ahead and ask your first question.
Hi. So I know you can hear me. So
yeah, go ahead.
I think they actually answered my question. So, but one of the things I wanted to know is if we could add new materials to the passive house ribbon that were not included in the library, but I think someone answered me that we can.
Yeah, that's right. You can in the UK version, you can certainly add them from EPDs. In the US version, we've already got a very large selection of materials there anyway. So with the 40,000 or soon to be 80,000, but you can also add them there too.
Great. Thanks a lot.
Thanks, Irene, for joining us this morning, and we'll head over to Bertie. Bertie?
Can you hear me? There's quite a lot of background noise. I'm in a cafe. Can you hear me okay?
We can hear you.
Nods?
How's the coffee this morning?
Yeah, great, perfect. Yes, good. I was wondering, so yeah, it looks like a really great tool, and I've actually got it, but I haven't used it yet. But London Plan, which is local planning requirements, now require, I understand, a whole life carbon calculation. And it was a question for Tim whether we can use his tool to demonstrate that.
I looked into this recently, and I don't see any reason why not. The London Plan has a list of requirements. I think they're all met. So yes, I don't see any reason why not.
And over to Chris.
Hello. If I understood Ben correctly, I think you said there was a bit of a financial disincentive to considering straw construction, that you were concerned you'd have, let's say, a unique and undervalued house if you were to sell it. So I'm wondering if there's any examples of financial incentives to counter that, so you'd be encouraged to build something with lower embodied carbon to begin with. And yeah, thanks.
Yeah, I think this is more something in my head. I'm talking about when you get to that point of selling your house and you only need one buyer. Now, what I was wondering about is whether it would put people off. If I'm totally honest, where we are in Hertfordshire, I don't think you will ever struggle to sell your house. Whether it gets knocked down and some person comes and puts their mad creation up, that is probably far more of an issue. But that was very interesting, getting the house valued recently, and the person walking around said, this location, I haven't seen anything like this, and I work this whole area. So there's a certain amount in that too. I think this is something that I perhaps had to get over and was worried about. Not in a big way, but yeah, it definitely put up a barrier. Maybe there were also conversations with my dad. There was certain family money that came into the house too, and he built his house in masonry, all the rest of it. Just these little things.
Thank you. So I guess maybe it could be a policy question, because I think you're touching on something that is a factor. But if there was a example of a financial incentive for people to really be encouraged to lower their embodied carbon, I'm wondering if anybody knows of those kinds of examples.
Yeah, I don't.
The only ones that I know of here in Vancouver is the city of Vancouver is looking at getting people to look at their carbon, and I know that this PHribbon is going to be used a lot here in Vancouver because the city of Vancouver wants to know the data, and I know that they will be proposing some grants here in Vancouver like they did to kick off the passive house movement here in Vancouver. So if you're in Vancouver, look for it. I don't know if you guys can comment for anything that's happening over the pond in your world, but it is coming local.
I don't know of anything happening in the UK except that there is something happening. The government are talking about possibly regulating embodied CO2. So there's this Part Z, which has been discussed in Parliament. It's been read out once in Parliament. It will be read out again in March. And after that second reading, then it may move towards being implemented. And that would mean initially people would just calculate embodied CO2, but eventually after a few years, up to 4 or 5 years, they would then start setting targets. And the building industry is quite slow moving, so it would need that time to get used to that idea.
Great stuff, Tim. We'll head over to questions for a couple more before we conclude the first hour. Dale, you with us still?
I've turned my mic on.
Perfect. Go ahead.
You. My question was more to getting this process started in Minneapolis. The architect designing her house had a big challenge with getting the building people to approve using straw because they had past experience where it molded. How do you get to the first step of getting somebody to approve using straw? It might be useful for us in the United States and Canada.
Yeah, I would say, Dale, it's Probably pretty easy to demonstrate that most construction types can develop mold pretty easily, not just straw. So yeah, you could fairly easily demonstrate, you know, through the correct build-ups that it would be resilient towards it. But I think in every location you'll have that kind of initial opposition to something new or different. But it's
It
about
wasn't new, they had past experience, so that's why they were scared of letting them do it again. And as for decision making, the wife ran the project, so there's no questions about making decisions.
yeah, I mean, I think it's just a challenge to convince people that it's safe, but yeah, not so straightforward. And it depends on the local inspectors at the time.
I think I could also mention something there. I visited a house, a straw bale house in Iowa. I was living there for a couple of years, and I went round one, and perhaps you can just point to other examples which have worked. There may be examples where there's been a problem, but there's plenty of other examples where there hasn't been a problem, and it was a delightful house to be in. So
yes, totally agree. Is there any reason you're using natural gas when you have all that wind in England? You're known for your windmills.
Yeah, that is a whole another subject that's quite interesting. So I had a gas connection in the village, and I ummed and erred about, again, you know, this is perhaps flawed thinking that I'm thinking of the future buyer would want a connection to the gas main that's in the village, and it's a lot easier to do it when you first build the house. But if I just put that money into an air source heat pump and gone straight to that, we've got all of our gas prices doubling, you know, perhaps again in another couple of weeks. I definitely would have asked Chris to do that differently, to go straight to the air source heat pump.
Thank you, Ben. In 74 years, I found thinking of the future is left for those who like glass balls, and just go for it. You're going to be okay.
Absolutely, Dale. Thanks for your question. Well, we've got a couple of things we need to discuss, but first, why don't we just do some thank yous, Ben and Mike and Hugh?
Yes, so I think I'd echo what, sorry, Mike, what you had kind of said. Ben, thanks so much for the kind of open, honest look into the process and the decisions, and Tim for helping us kind of understand that. It's enlightening, and yeah, should help other people make good decisions. So thanks. Over to you, Mike.
Yeah, thanks, guys. Just echo what Hugh said, and I've also had a personal desire for straw construction for a long time myself, so it's just nice just to think about it, if nothing else. But thanks very much, guys.
Yeah, and this is something that I want to do. I definitely would enjoy looking at some different build systems. There's a friend of mine who might be going down this route, and I might get the opportunity to film the straw panel construction and just see it all firsthand. That's what I'm really excited about and interested in. In terms of the subject, embodied carbon, I think it's an important one. There are all sorts of things, as we've discussed, that you need to get right, and that we as a construction industry need to sort out. So lots there. I'd also like to thank Tim for stepping forwards for this, and also Chris. It's lovely to see Chris again. Bring him out of retirement for the day. Thank you, Chris.
Yeah, thanks for joining us, Chris. Great insights, and again, great developments of what you've been up to. So it's fantastic. Well, again, at the Accelerator, we're extremely lucky to have so many people involved, not only the team here, but also the sponsors. So it's a great opportunity to thank them. So start off our founding sponsors: 475 High Performance Building Supply, Baxingwe Architects, Glavel Foam Glass Gravel, Minotaur All-in-One HVAC Units, Mitsubishi Electric Train HVAC US, Martel, Rockwell, Stowe, Zola. Our champion sponsors: Icon Windows and Doors, Proseco, Siga. We also have our stakeholder partners: New York State of Opportunity, the NYSERDA, and our patron sponsors. We've got a big list now. It's growing. It's really exciting to see this list grow: Aero Airgrits, Air Barrier, Brennan, Brooklyn Solar Works, Euroline Windows, Innotech Windows and Doors, Lamlux, Owings Corning, RDH Building Science, Sanderson Sustainable Design, and US Engineered Wood Teasted. So thank you to our sponsors. Back to the questions, and let me just pull up my list. And we are going to Sarah. Sarah, are you still with us?
Yes, I am. Hi. So yeah, I'm also joining from Canada actually with a prefab panel manufacturer in Ontario. We're called Tree. So my question was just about the name of PHribbon because it has PH in the name. Wondering if it's just for passive houses. I was told that no, it's not, but you know, we build some passive houses, but some clients don't want to go all the way that far. So just wondering, yeah, is it just for passive houses? Why choose that name if it's not?
Well, the link is really with PHP more than it is with Passive House. So we've got a link. The PHribbon is an interactive thing that links to the PHP, and it has a lot of functions that it integrates with the PHP with. Well, PHP also is called the Passive House Planning Package, but again, you don't have to use it for passive houses. You could use it for something slightly less. So you've got that in the name too, but you've got the flexibility, haven't you? Passive houses, of course, the great ideal for a passive house is that if you do have a passive house, you can eliminate all the thermal bridges. Whereas if you build something less than a passive house or a retrofit, you have to include all those thermal bridges, and it's a bit more complicated. So it's a bit more involved doing it not as a passive house, but you might have a client who wants to say, well, let's compare a passive house option with something less than a passive house option, and then you're still using the same software, still using PHP. You're not actually necessarily going for a passive house in the end.
Yeah, it's great now that we'll have one resource to be able to pump out lots of great information and be able to make the choices. So Tim, appreciate all your hard work to get this thing going. I'm looking forward to seeing more projects here in Canada using it as well as in the US. Sorry, back to the queue. Thank you, Sarah. And again, love the work you're doing with prefab. So thanks, Sarah, for joining us. Bertie, we're going to go back to you if your cafe will allow it. I think you answered all your questions, but just want to give you another opportunity. Stephen.
Yeah, the question is just around if the buildings are becoming more lightweight, how does this impact overheating overall within them? Because if the temperatures are set to increase in the next few years, wouldn't lightweight buildings in essence mean it's becoming more an overheating risk?
This is more of a PHP question, really. And lightweight building doesn't necessarily mean it's going to have a much higher overheating risk. Because with a passive house, you have a very well insulated box, and you minimize the inputs in and out. So you minimize the amount of heat gain as well as in some cases having some thermal mass. Thermal mass isn't that useful unless you've got a large temperature range, in which case it does help a little bit. If you're only talking about a few degrees with a passive house, then it doesn't really influence the temperature all that much. You can explore the overheating risk anyway in PHP, and we always do that because it's part of the requirement. It doesn't seem to be that huge a factor, and you can explore future climates as well by using, there's a tool that's available to look at future climates that's available from Passive House Institute, and that adds this extra few degrees onto the summer temperatures, so we can explore that. But yeah, it's an important part of it. It's certainly a very important consideration. I wouldn't be too worried about it having a timber frame house and then worrying that it's only going to overheat too much. That's always considered in the calculation.
I think that answers it, Tim. And again, versatile gentleman. He knows all these, not just about the PHribbon, but also the details. So great answer to that. I would have said the exact same thing. Moving along, Margaret Reynolds was looking for a link. I'm not sure, Margaret, if you got it. I thought I did see a few things. If not, we can try to find you that link. And Chris, we're coming back to you for a question. Are you still with us?
Yes, thank you.
Go ahead.
So the 50-year disposal part of the presentation seems a bit arbitrary, and I'm wondering if that's due to some regulation, or is there another graph / report that would give a more realistic end of life calculation based on the actual building's expected lifespan? And if second to that, is there a threshold that if we say, hey, we're about 5 to 10 years away from a zero carbon emitting method of disposal, could we basically just zero that out because we're that close to using it?
Okay, well, the first part of that question, the 50 years, is actually 60 years is the consideration in RICS. That's the standard time. And the reason they pick 60 years is because it's the minimum life that we'd expect out of a building. And I know that everyone says you'd want a lot more from your building than 60 years. You at least double that. If you didn't get double that, you'd think yourself shortchanged, really. So yeah, I understand that, but then at the same time, you've got to be able to compare two buildings. So you have to be able to look at one building with the same overall lifespan as another, because equally you could say to any of the buildings, well, it's probably going to last with some replacements, repair, maintenance, they're probably all going to last around about the same kind of time. You've got to be able to pick one lifespan. And so that lifespan has already been chosen for us by the EN standard, and it's 60 years. There is a European standard which goes at 50 years. That's a different thing. So that's why we choose 60 years. There is a way in PHribbon, in the UK version, of choosing a more appropriate lifespan. So you can choose anything up to, well, only Simmons wanted to have 500 years. And I think that's quite optimistic. Not impossible. There are lots of churches and things that old, but yeah, so it will go up to 500 years, and you can have whatever you like, whatever you think is feasible. And the second part of the question, though, if you have in 5 or 10 years, you have a net zero threshold. I didn't quite understand what you mean by that. What can you explain a bit more?
Yeah, the time of how soon the technology is available is the threshold. So now we're talking about the soon to be available carbon capture, sequestering CO2 in bedrock, for example.
Right.
And they're almost, so if there was some kind of nearly available technology or method of zero emission disposal of a straw building, could you then consider that in your report?
Well, I think it would be down to local decisions about whether it's acceptable or not. I'm only providing the calculation, and I think there aren't actually yet guidelines that I'm aware of in the US. There might be soon about what has to be included in the calculation, how it's done. And in the UK, we're very conservative about what is actually assumed to be available, and until it's available, we can't actually have it. It would have to be omitted, but there's no reason why you couldn't say, supposing this was available, it would give you this answer. I mean, it's really up to you to produce the narrative for what you want to say. And until there are guidelines, actual regulations to say, well, you've got to produce this, then yeah, just use it to help make your case, really.
Great questions there, Chris. Over to Eugene.
Thank you. Thank you very much to Tim and Ben for a very insightful presentation, and to all the crew there hosting it. I'd just like to echo some of the things that were stated earlier on regarding the way things are going certainly in the UK and in Ireland in particular. Soon we won't be able to have a fireplace anymore. So we're all going to be turned on to heat pumps and so on, which is going to change the economics of the whole thing, and that'll be very interesting to see how it pans out. But to get back to, if I may please, Tim or Ben, ask a simple question. In the Republic of Ireland here, we have building energy ratings, BER, and BER of G is the lowest, therefore the most expensive to run in your utility bills, and BER of A is the highest, so it costs less. does your system, I know, of course, I'm beginning to learn now a little bit about Passive House. It's a little bit different to the standard thing. But how, is there any direct comparison, Tim, with a BER rating here in Ireland? Okay.
Yeah, Passive House is a slightly different calculation. You use your calculation is called DEEP, isn't it?
Yes.
And it's the equivalent of what we call SAP in the UK.
Correct.
And we did some calculations for the Passive House Association Ireland on a few houses, which we looked at 5 or 7 different constructions of just a building that met the DEEP, that is the standard building regulations minimum standard. And we published that got published in the Passive House Plus magazine. And it showed really a surprisingly little difference, except that when you start going down to timber and cellulose, that was quite an improvement. And we changed the wall type and we changed the floor type, and had several different options, different renders, different finishes. Sorry, remind me of your question again. I'm wandering off probably.
No, it's okay. It's fine. You're on point. It's BER ratings, you know, and
BER ratings. Yeah. Well, so yeah. BER ratings. Well, the Passive House planning package can still be used. You still have to do a supplementary calculation of the BER rating, just as we have to in the UK. We have to do a supplementary calculation for the regulation side. We have to do a SAP calculation as well as the PHribbon, because they're not accepted. PHribbon isn't accepted as far as the regulation is concerned. So while you have to do both, we all know that the Passive House calculations are more detailed and more thorough, and I think you should pay more attention to those. But you still have to do the standard calculations as well, and you get a slightly. Sometimes it can be a very puzzling result. In the UK, we get Passive houses turn out to be a B generally, something like a B, not an A in SAP.
But Tim, you could use the SAP information in a different way, couldn't you? Is it not a lot about the calculation, because they do measure air tightness and so forth?
Yeah, well, there are certainly similar things. There's differences in the way SAP approaches things compared to PHribbon. There's certainly similarities.
Yeah, the reason I'm dwelling a little bit on this and putting it out there is that it's really going to take off here in Ireland now. We're going to have to start, you know, either retrofitting our homes, and you know, the government are going to give grants as they do in the UK. And so the grants are driven by the BER assessment. And so before you carry out any works, you have to have the initial BER assessment. And then when the works are done, you carry out your final BER assessment. And based upon that, the grants are delivered. So the grants are quite substantial now, you know, in some cases they're going up to 25,000 euros. So it's important that there is some kind of correlation, because everybody will be asking when they hear the man in the street, when they hear about Passive House, they say, oh, that's very expensive. No, I don't want to go for that. I need the bare bones BER. I need to be at a BER B2 rating. That's me. What do I have to do to get this? And your calculations, how do they stack up with that?
Yeah, usually it's really interesting what you say there, because running a website all about house building, my friends know that. So I've had a few friends contacting me with similar sort of things, saying, oh, my energy bills are so high, what do I do? And then you explain what you need to do, and they sort of lose interest a bit, almost looking for that quick fix. But moving to an EPC band, different band's not going to help massively, is it?
I think Chris could say something. Chris Parsons, you might be able to say something about the cost, because I think, if I remember rightly, your Wimbish design, that wasn't more expensive. That was pretty much similar cost to normal build, wasn't it?
Yeah, thanks, Tim. That was certainly one of the things which the client liked to promote. But what he's actually talking about is we managed to get the valuers to increase the value of our passive houses because they were passive houses, which helped their financial calculation. I think that's probably what you're thinking of. Most of our passive houses that we've built to date have cost somewhere between 10 and 15% more than what we would expect for a standard build. And I think a lot of that is down to the fact that most of ours were still quite early adoptions, so there's still a lot of shortage of materials, etc., etc. Just on the EPC, BER thing and everything, I've been doing a bit of work on this lately because all of our government legislation is presumably like in Ireland, centered around the EPC ratings, and we're being encouraged to get to higher EPC ratings. But it's always important to remember that our EPC rating, as against the stuff that comes out of the SAP calc, which you talked about, the EPC rating is actually adjusted for cost of fuel. So it doesn't make a lot of sense as just looking at the EPC rating to make a determination about how carbon efficient or how energy efficient your house is. There is information, however, in the underlying SAP calc that is quite useful. But governments like shorthand, so we're kind of strapped at the moment with EPC, and it sounds like you might be doing the same in Ireland with your BER. It'd be so much more important to get to the underlying information either through the PHPP calc or indeed from what comes out of a good SAP calc, or whatever yours deep, I think you said.
Okay, thank you very much. I don't want to hog the line here. If anybody can send me a link to that Passive House magazine report and something that might help me, I'd be much obliged. Okay.
Sure, Eugene, we'll work on that. And again, great points. And again, it was a good discussion, so don't worry about dragging it on. So it's very interesting. So moving along, we had Ruxandra had a question, and then we have Zoe, and then Mark, and I think that wraps it up.
Hi, everyone. Thank you so much for all the great information shared here. Quick one for Tim. Is there any information on hempcrete to feed into the PHribbon to assess embodied carbon? Thank you.
I think I'd have to look. I think there might be. Yeah, if there's an EPD for it, give me a minute. I'll reply to that in a moment.
Thank you so much. Thanks.
All right, moving along. Zoe, I know you had a question. I think Vlad helped you out with the information, but Zoe, if you want to dive into that question more, go ahead and ask it.
Thanks. I didn't see the chat, so if the link is there, then thank you very much, Vlad.
So the question was just about overheating and gating the data, which Zoe put in there, getting the summer temperatures. I know this is a couple of years old now. Again, it's like a pre-COVID discussion where we're talking about the PHP, or sorry, the PHP had old energy data. And so when you wrap up your PHP, when you're doing your kind of final examination, you just want to make sure that you've got some future data and future, weathering model to make sure you won't overheat in the future. So there's some great insight there. Mark, I think you get to wrap up the questions. Mark?
I would have to say, I do not honestly recall my question because this is such a learned conversation. Every time each of you spoke, it took me down another rabbit hole. Very impressive. And with these rollouts that you do, just know that your community is applauding it because this example is setting it for other places. So my questions are never ending, but the inspiration comes with it. Thank you, folks.
Thanks, Mark. That's a great way to wrap it up. So Mike, Hugh, Chris for joining us, Ben for diving into your house, and Tim, this has been a great episode. Hopefully everyone will come back in about a month's time to continue. Go ahead, Tim.
By the way, on the hemp, yeah, there is an entry for hempcrete in the UK version. There's not in the US or Canadian one because that's based on the EC3 database, which doesn't have it, but there is potentially there's an EPD for it, so it could be added. So yeah.
And again, Tim, the work you've done is great. I mean, here in North America, the embodied carbon, the Geez, you can tell I'm still waking up here. The Carbon Leadership Forum has grown exponentially in the last couple of years, and it's great to see a bit of a merger with our ideas and our concepts, so that we're not only building high performance buildings, but we are looking at material choices. And so we can actually, again, create a real zero carbon building when we've got all these great decisions and modeling factors. So great work, Tim. Looking forward to seeing more projects here in North America. Just to highlight, when we did have a feature on the accelerator of a building in Portland, that they were planning and described that this building will last 500 years. So there's definitely people out there pushing forward. I know that we kind of talked about building 100-year buildings. Well, most of the buildings here in North America have lasted 100 years. So now it's the big push for 200 years. So there's definitely these discussions about making sure that the mechanicals might need to get changed out a couple of times, but at least the envelope is built to be long lasting so that we can carry things on. And you're right, this whole world, Eugene, you talked about retrofits. We got a lot of buildings to retrofit because we're moving ahead into high performance and changing our cabins and our shelters into high performance. So keep leading the way. And yes, humans, we've evolved from being cave people. We are now going to put our fireplaces on the outside of our buildings and make sure that we've got buildings that have fresh air, good assemblies, and then we can enjoy the comforts of what shelter is supposed to provide for us. So from the House Accelerator, we will call this a wrap, everyone. Thank you for joining us. I look forward to another early morning in a month's time, but you can always catch us next week. And if you're missing us, go to the podcast. With the work that Zach and Matthew Cutler-Welsh do is fantastic. So enjoy the podcast. Otherwise, see you next week. Bye, everybody.